Let us understand magnetic field due to a current carrying circular loop. Think that this is a circular loop and you can use right hand thumb rule for identifying the direction of magnetic field around a circular loop. Think that current is flowing upward here and my thumb shows the direction of the flow of current. So you can see the encircled fingers are coming from outside to inside. That means the magnetic field obtained here is outside to inside. And at the same time, if you hold like this, in this way, in the upward direction, then you can say if the current is flowing in this way, it is, if you hold like this, it is from outside to inside. If you hold like this, if it is inside to outside. So you can easily understand. Now let us understand magnetic field produced by a circular coil. As you know the setup using a battery, key, a wire and a cardboard. As soon as the current starts flowing through a circular coil, if you place a magnetic compass around the coil or a iron fillings, and if you tap it, it will arrange in a concentric circle. This shows that the magnetic field produced around a coil. If you observe properly at the center, there will be no circular arrangement of the iron fillings. This shows that at the center of the coil, the magnetic field produced is parallel. And here there are two factors on which the strength of the magnetic field in a circular loop and a circular coil depend. First one, the radius of the coil, and the second one, the number of turns in the coil, and even third one, strength of the current. First factor, as the number of turns increases, the strength of the magnetic field also increases. We can state like this: the strength of the magnetic field in a current carrying circular wire is directly proportional to number of turns. The same way, the strength of the magnetic field in a current carrying circular wire is directly proportional to amount of current flowing through it. In only one case it is inversely proportional, that is, as we increase the radius of the coil, the strength of the magnetic field decreases. As we decrease the radius of the coil, the strength of the magnetic field increases. So the strength of the magnetic field around a current carrying circular wire is inversely proportional to radius of the coil. Let us understand about the solenoid. If any cord or a wire is made into circular, then it is connected to a battery and a key. Such arrangement is called solenoid. So a solenoid resembles a bar magnet and it produces magnetic field same as that of the bar magnet. So a few points we have to remember here. The magnetic field produced by a solenoid, outside it is non-uniform, and outside it appears as if it is moving from north to south pole, but inside it appears moves from south to north pole. Always the negative side of the battery is north pole of the solenoid and the positive side of the battery shows the south pole of the solenoid. Here also there are two factors on which a magnetic strength of the magnetic field depends. As we increase the radius of the solenoid, the strength of the magnetic field decreases, and as we decreases the radius of the solenoid, strength of the magnetic field increases. One more factor, that is the number of coil. If we increase, definitely the strength of the magnetic field also increases. Even the amount of current flowing through the solenoid, if we increase, definitely the strength of the magnetic field also increases. Hope you all understand about all these. One by one I will repeat. A current carrying straight conductor, a current carrying circular loop, a current carrying circular coil, and a current carrying solenoid. All these produces magnetic field There are several questions they may ask you this regard, the factors, to draw the diagrams. Hope you all understand and learn this one.